Thanks. Well, this kind of brings me back. Up until 10 years ago, I was a professor, and so this would be my kind of daily environment. I tried to get away from that. So if I get into that aspect, if I start handing out homework or something, I just throw something at me and wake me up. Of course, then people didn't look as awake as you do. So I'll probably be fine. So the thing I wanted to drill into today is one of those wonderful questions that seems to have a completely obvious answer, and once you start thinking about it anyway, good things can happen. And that happened to us on the what we call the managed languages team, the C#, Visual Basic, and F# team, though F# isn't part of this story. I'm sorry. You can ask me about it later. But it was this, essentially we found ourselves in a pretty tough spot. We were still on a C++ code base for our support for C# and Visual Basic that had been thrown together in a rush when V1 had to go out. You know how it is. Throw something together and keep piling onto it and try to clean up the architecture later, but not quite because this or that. And so we were in a sort of messy code base that we were scared of supporting for the C# compiler and the C# IDE experience as well. Actually, two different code bases that we were equally scared of, and were equally messy. So we had this very concrete gripe that we were hindered from doing all the kinds of things we wanted to do to evolve the user experience. I'm going to say C# a lot, but most of what I'm talking about today applies to Visual Basic as well. If somebody here has that close to their hearts. What's the sniggering? What was that? Who started that? Out. I guess before I go in too deep, before I lose myself in this fascinating material, how many in here are familiar with C# in your own estimation? Okay, that's a few. How many are not? Oh my God. You guys, are you sort of self-selected? If you don't know C#, you don't feel welcome here? Are the rest of you VB? Because then I apologize for this guy here. It's totally unacceptable behavior. So, we found that when we wanted to evolve our languages, like new language features, it was really hard to do. We found ourselves not putting in little features that would be convenient because the price and risk of doing it was just too high for it to be worth it. We would only do like really big stuff, and the same was the case for the tooling experiences, the IDE experience in Visual Studio, and so on. We were held back from evolving it. We didn't have any way of enabling other language-based tools. People who were building FXCup had to do it on top of IL instead of on top of source code because there's no way for them to understand the source code. People who built StyleCup tried to do source code, but they had to build their own parser and so on. We didn't support anyone else but ourselves, let alone other IDEs for C#. That was just other IDEs than Visual Studio. Who would ever want to do that? Especially when they pay us so well for it. So and agreeing on semantics even across the things that did because of these separate code bases was just a mess. So we were in a sufficiently bad spot that the answer to this, the managerial answer to this proposition above here, let's rewrite the whole thing, which is usually very stupid and should not be undertaken, that eventually became yes, let's do it, let's try this. Because otherwise we are not going to make progress in the long term. So we embarked on rewriting the compilers for C# and VB completely from scratch in C# and VB. This is back in the aughts, in 2008 or thereabouts, that we embarked on this, and we finish and ship in 2015, the summer of 2015, with Visual Studio 2015. So you can understand why people are skeptical about us undertaking a project of this size. And the only reason we could do it is, we could defend it, is that not only do we have a better code base, but we also have opened up a vast array of new things that you can do with this code base. And so I'm going to go into that a little bit. But first, let's talk about something that, like, we're in school now, and somebody mentioned earlier here today that when you go to school, when you take computer science or software engineering, it's sort of like a rite of passage or whatever to be taught how to write a compiler. Like, not a lot of people actually have to do it in real life, but anyway, they teach you how to write a compiler. It's very important that you learn that, and I'm here to tell you that what you learned was wrong, by and large, or it was an oversimplification of the real world. But anyway, so the sort of classic model that you get is that a compiler and an IDE or an editor, they're very, very different things. They are very different things, and they have very different constraints on them when you want to build one. If you're building a compiler, you're all about, this is a batch thing, you're producing source code out the other end, it's a pipeline, you're optimizing for throughput, you're interested in the code being correct, and you'll tell a user if the code is not correct, and you'll tell them in a very harsh way where they don't actually get to compile and run their program. So it's all about preventing badness from happening when you run, and it's all about processing the code you already wrote into something else. Contrast that with an editor or an IDE where the performance measure of an IDE really is responsiveness. It's not throughput. It's how quickly does it understand what you're doing as you're typing in real time. You want it to be error tolerant. You want it to be so that when you type some half-finished code up here and then some down here, and maybe there's a bit of a syntax error somewhere, it still by and large understands you. The more forgiving it is, the better. It should see through your errors, through the errors of your ways, and be forgiving and still understand what you're trying to say, right? It's about enabling goodness, about letting you be creative and productive. And so therefore, it's not just about what you already wrote, but it's about what would you possibly do next. Enabling that with completion and navigation and so on, kind of laying out your options in front of you in as productive a way as possible. So they're very, very different. They're fundamentally different scenarios. But they do have something in common, which is pretty important, which is that both of them understand C#, right? That's the core thing. They're supposed to understand the language. And not only compilers and IDEs are supposed to understand the languages, but many, many other things that exist or that you could imagine existing for your programming language are about understanding the language, understanding source code, and producing source code. So think about if you wanted to produce your own diagnostics. I mentioned FXCop and StyleCop, things that tell you other things about your code. Those are things that rely on language understanding, as are transformations of source code, be they like live refactorings or batch tools that you run that may fix your code or upgrade to a new API or new version of an API that you want to write a little tool that replaces this call with that call, or all kinds of scripting scenarios where you may be coding live against you're intermixing coding and executing, like a REPL, which we have now as of last Monday. Woohoo! In Visual Studio, we have a C# REPL. Let me just ask, how many have Visual Studio 2015 Update 1 already installed? Yes, go. Have you tried the REPL? Okay, it's a little bit buried. Maybe I should show you where it is. Let me show you where it is. Look. Come on, guys. It's such fun. Under View, you go to Other Windows. And then right there at the bottom, where the latest added thing is C# Interactive. You click it, and you have a REPL for C#. Come on, 2 + 2. Submit. The world's most advanced calculator. Yeah. Right? It's a fancy look. It has completion, and I'm on a tangent here already. But they said I had a whole hour, so bear with me. I wasn't going to show this. People who are going to Yao, I'm sorry. I was only going to show this at Yao, but I got sidetracked. I sidetracked myself. using static system.console. See, it's like a combination of an IDE and a REPL and a classic REPL, which is sort of command line. Like I do that, and now I can say write line because I brought all the static members of system.console into scope, so we can write line hello. This is an interpolator string. How many people have played with C# 6 yet? Yes, there are interpolator strings in this language now, which means that I can put a dollar in front of my string, and then I can put little holes with curlies around them, and I can say, hello, DDD Brisbane, datetime.now.year, and it will print out, oh, great, yeah, whoa. Back to slides. Aww. No, really. I have another demo later. We'll get there. Okay. So there's so many things like generating documentation. Yeah, there are tools for that for various languages. But wouldn't it be nice if they really, really understood your code? If they're able to deeply link up things, all kinds of static analysis on your source code. Telemetry, various aggregation scenarios of across vast amounts of source code. All kinds of things can be built. We've built some of them already with Roslyn now, but back then when we were motivating ourselves, we weren't even dreaming of half of these, right? But they sort of came as managers started to look at us hungrily and say, well, it's the time we shut down this project. We kept coming up with new things that would be really cool to do, and we made it through. Meta-programming, right? Injecting extra source code based on what's already there in attributes or name patterns or whatever, weavers and stuff. You can just imagine all kinds of things that you could do that involved understanding the language. And so really the credo for Roslyn, the Roslyn project, our rewriting of the compilers is there should only need to be one source space in the whole world that understands C#, right? We should write something that everything in the whole world, everyone and everything that needs to understand C# or generate C#, they can use that. Okay, cool enough? Yeah. And of course, it's a little, if you were sitting there going, damn, I wanted to have been the one to write that. But there can be only one to rule them all. So come and contribute because it's open source. So having just one source base that services all those scenarios, all the interactive ones as well as all the batch ones, that really led us to a model of a compiler is not just this translator, right? A compiler is really a service or an API that understands source code. It is a faithful model of source code, an object model, if you will, of source code that you can explore as an API. And that's what we built. And for it to actually be applicable to all these scenarios, whether we do them as Microsoft or other people do them, it has to be open on a whole lot of different dimensions. So first of all, it's completely open source, right? Our stack is getting more and more open source, actually starting way below what I'm talking about today. The new .NET Core stack has an open runtime, an open library, and then comes the Roslyn compilers on top being completely open source, and our VS integration up to a certain point where it becomes the proprietary code over there is completely open source. And it's open source not in the way that we sort of throw our code over the fence once in a while and display it on GitHub. We work on GitHub. Other people contribute to our code, mostly us, but other people do as they gain, as they start to want to use the source code for their scenarios, and we want to keep it being the only source base they need for this. Xamarin, who do Mono and C# support for iOS and Android, they have contributed some things that they needed in order to now build on this code base and so on. So Open source allows us to show all we're doing and also take a whole lot of stuff in and make it more of a community thing over time. The API itself is public and open. It's complete. It's a complete API in that it represents publicly everything you can do with the language, pretty much. If it doesn't, we'll probably build it. So our whole IDE integration, for instance, is completely built on the public API all the way down. It's the public compiler API. It doesn't have some kind of a special handshake or with secret code. It's all open source or public API in all layers. It's cross-platform. C# runs on many platforms, and so does Roslyn. So runs wherever C# runs. And the design process as well of many things we do, including the language design, happen in the open now. There's discussions in GitHub. That's where we kind of track what we're doing. So we've opened up to a whole new world here. And we're already seeing more and more scenarios that are being built where we're pushing the boundaries for what you can do with a programming language, or with tooling around a programming language, I should say. So let me get a little teacher on you here. Let's talk a little bit about some of the different. How many people remember anything from when they're forced to learn about compilers? Yeah, that's why we probably shouldn't be doing it in the first place. Were you forced to learn about compilers? Many of you were here. How many people were forced to learn about compilers? Okay, it's about half. Okay, many of you got. Okay, yeah, it's actually quite interesting, but it is a bit of a corner case of the world, I would say. The main thing I want to get into, I think, I don't want to talk go too much into detail about all the compiler technical stuff. The main thing I want to get into is that most of you know there's something called syntax trees, typically in a compiler, which is like a tree of syntax. Okay? What is that really? Well, it's an object model of the source code you wrote that represents its physical structure, right? And syntax trees are often abstract syntax trees. They're called ASTs because they're abstract. And what it means that they're abstract is that they have filtered away all the unnecessary detail that you don't need in order to understand and produce the semantics of the code later. Okay. These are not abstract syntax trees. These are concrete syntax trees. They're as concrete as they get. They're dripping with detail. They have everything, like every white space character, every comment, everything that is completely useless to a batch compiler in terms of finding out what code to generate is still there for all those other scenarios. Like, say you're building a refactoring. You want to shuffle around some code. You want the formatting of that code to stay the same. So if you do that through this object model, it has to keep all that stuff around. So these are completely concrete, round-trippable trees. If you press toString on them, you get the source code back out, essentially. Okay, and it's an object model that's very accommodating. Unlike typical compiler trees, it can accommodate code that's erroneous, and is trying to be, instead of narrowly sort of wrapping around what's correct, it tries to be really accommodating. An interesting aspect of this that I don't know if I think it's probably going to be interesting to you, especially when I show something a little later. But it's also, so it's interesting that we are doing it, but it's also an interesting approach in general, which is that even though syntax trees are a vast data structure representing like enormous source bases sometimes, we do them as immutable data structures. A syntax tree is not mutable, okay? It never changes. If you have one of these objects in your hand, it will not ever change. Instead, if we want to represent a change or a delta, like somebody typing in the IDE, or some tool having produced a new version of the source code, we do it with a completely new tree, logically speaking. It's a syntax tree that is a new value and that can coexist with the old one. Of course, in practice, we try to make that, or we do make that efficient, I should say, because we don't just try, we actually succeed. We make that very, very efficient by sharing everything that can be shared between those two immutable trees, which we can do because the things that are shared won't change, right? So nobody's going to get confused. So again, this is something that people typically, just like this unification of the interactive and batch scenarios is a little unusual, and people don't usually do it. People also don't usually end up having immutable syntax trees because it's hard to make efficient. But we've done it for very good reasons. It means that we can parallelize the crap out of this compiler, right? We can work with many threads, compiling things at the same time as much as we want, because we don't have any shared state, right? There's no shared state if there's no state, and it also means that it's very easy to represent the before and after of a given operation, and we'll see that in a demo in a minute. How that becomes very useful, right? You don't lose any information about what was there before, and you can compare the two. Okay? Yeah. See, there's also a semantic model. It represents like how names bind and stuff. It's also immutable. The whole thing's immutable, like everything's immutable. There's a workspace layer that represents the kinds of things you want to do in interactive scenarios. It helps deal with completion and navigation and refactoring and classifying things so they can get colorized and all that. It's also immutable. Everything's immutable. The only thing that's not immutable is that somewhere in there's something that represents, think of it as a single variable at the top that's mutable, that represents what's in the editor right now. If you're making an IDE, there's one mutable variable, and you assign a new tree every time you press a key, okay? Or do another operation on the code. The workspace layer that is supporting editors, essentially, that's there to support editors, most of it is an editor agnostic layer that is equally useful to VS as to any other editor that wants to use it. Okay, so Sublime can go and use it to integrate C#. Now, there's this little problem. This is written in C#, and you can't run C# inside of Sublime. So what do you do? Well, there's a community project that's already taking advantage of Roslyn called OmniSharp that takes Roslyn, takes the compiler infrastructure and wraps it and runs it as a separate process on a machine, and then they build a thin integration layer in Sublime and in Emacs and in Atom and in many editors that just talks to that process, that sort of has all the knowledge represented in and does all the heavy lifting, right? So the process that runs the IDE just talks through an HTTP channel to something that knows everything and is running C#. And so through this architecture, it's very easy to get very good C# support in the editor of your choice that runs on any machine that can run C#. And hey, if you have an editor on a machine that can't run C#, it's an HTTP channel. You can probably just run Roslyn on a different machine. Okay? So we're really trying to make it so that C# can be everywhere. Gone are the days where C# is just for Windows programmers running Visual Studio. We want it to be in the places you want it to be. Yeah. There's this thing about performance. There's a reason why people don't unify on one code base. It's because it's usually very hard to get things to be performant both in a batch and in an interactive scenario. It's also very hard for us. And it continues to be hard. So that's really the Achilles heel of this approach. But we have a V team, a performance V team, a virtual team that is constantly vigilant. We run hundreds and hundreds of thousands of regression tests on all kinds of performance scenarios, on automated things that press the keys very fast and try to see if we can keep up with all kinds of feedback in the IDE and so on. And we frequently, when we do a change, we fail those, and it's hard work to go and make the thing performant again. So that is really the biggest challenge of a system like this, is keeping it performant. So the good news is it is very, very performant. It compiles as fast, as long as you have at least 2 cores, because we parallelize. It compiles as fast as the old C++ code base, which was known to be a fast compiler in C-sharp's case. And it also is as responsive as any IDE experience we had before, and actually better. So we have all kinds of goals, measurements of the old stuff, and we take a very data-driven approach to keeping everything performant. And it's hard, but it's worth it, because every time we evolve the language or implement expose some new functionality, some new aspect of the language, everybody benefits, right? So having that core thing is so valuable that it's worth the trouble. Hey, they pay us pretty good. It's okay. So I want to, in a minute, I want to dive into a particular scenario that is newly enabled by this. Before I do, I want to ask quickly if there are any questions so far, because we can take a few questions before we go into depths that we may not be able to return from. Yes?
Yeah, if it's creating a new source tree every time you hit a key, how does it keep up?
If it's creating a new source tree every time you hit a key, how does it keep up? By being very smart and reusing 99.99% of the old tree. So a tree is essentially, a node with some pointers down to some nodes, with some pointers down to some nodes. And if you think about making a little change in one or two of the bottom nodes that represent like the concrete tokens, you can do that. You can create a new tree that's like the old one by replacing just the path from that node up to the root, right? So it's essentially logarithmic in the size of the tree. It's just the height of the tree, essentially. If you think about your depth of indentation, that's roughly, how many nodes need to be replaced. It means that we need to have a very nifty incremental parser that can parse only the parts that are changed and figure out that the others would parse the same. Like can kind of check that and break down just enough that it keeps everything that parses the same. So at the parsing level, it requires some nifty technology. And at the data structure level, it also requires some nifty technology.
Store a whole complete copy of the new tree, or just the deltas?
No. So it just creates the nodes that are the deltas, and keeps all the old ones. Just points to the old ones.
Kind of like Git in that sense.
Yeah, exactly. Yeah. So Git is also an immutable data structure, right? So you should have a feel for this. Now, one thing I do want to mention, and we can see it a little later. One thing that is that is so painful that it's unacceptable about syntax trees that are reused again and again is, hey, if I add a character up here early in the stream, then yes, the syntactic structure of everything else remains the same, but it all shifts a character, which means that node can't represent its its absolute position, because it's being simultaneously used in two different trees where that code sits at two different absolute positions in the buffer. Even worse, it can't refer to its parent, because it might at different times have different parents, because things get reparented when you replace that string all the way up. So how can you work with a tree that has no absolute positions and has no parent? You can't. Okay, so we actually, so this was I still remember the meeting where we sat down 7 years ago or whatever and said, what are we going to do? We want to use immutable trees, but the usability of them, of a data structure like that is unacceptable. I mean, somebody gives you a node, you can't ask where it sits, you can't ask where it is on the screen or what it's a part of. How can you write any code over that? Right. So we came up with a fancy data structure that we call red-green trees, because the day we had that meeting, we had a red marker and a green marker at our whiteboards. I have neither here, I think, so you'll have to just consent with me waving my hands. Essentially what we do is we do have that tree that where everything but a very small percentage is shared through an update, but that tree is private and not exposed. The thing that's exposed is a layer on top of that is lazily generated, that whenever you go down a certain path of that unidirectional tree, if you will, that arrows down only tree, we compute a new node that is an overlay of the old node, but remembers the parent it just came from, and computes its absolute position and so on. And so we have a combination of an incremental tree underneath and a lazy tree on top that gets generated, that lays out the tracks as the train is driving, essentially. And we do that from scratch every time you have a new route. Right? Okay, so it's a complicated data structure, and that's part of why it's hard to keep this efficient, because it generates a lot of little objects with a lot of memory pressure. But it works, and it's like magic. Right? It's like magic, except for the fact that we're open source, so people can see what the trick is, and you can go and do it yourself if you want to.
I have another question for you.
Yes.
Do you guys expose events over the API for the actual syntax tree changes?
Where are you? Wave your hand.
Sorry.
Do we expose events?
For the syntax tree changes?
No.
Okay.
Because what would those events mean, really?
Give you a diff of which part of the code base may have changed. So
Right. So we do expose the ability to do a diff.
okay.
But there's no real event to expose. The event would essentially be, oh, I just wrote into that root variable up there.
Okay.
Then you can diff, yeah. So if people have been scratching their heads about propagating events and updating things and making sure you don't go into circles or inconsistent states and all that, none of that stuff here, because it's immutable trees. It's very easy to reason about.
Sorry, one more question.
Yeah.
Like you said that you really want to make sure there's only one code base ever.
Yeah.
So what do you think of JetBrains' decision to kind of keep their own tooling? And do you think Roslyn could ever reach the point where you can support their requirements?
Right. So the question for those who can't hear is, what about things like JetBrains that have their own model, and could Roslyn ever satisfy their requirements? The answer, I think, is yes. I don't know their model because I believe it's proprietary, So I'm not sure what they need or what they don't need. I am pretty sure that they could achieve their goals. Technically, they could achieve their goals by contributing some extra functionality into Roslyn and exposing that as part of the public API. But their monetization model would probably suffer from that. So I understand why they're not doing it. However, DevExpress's CodeRush actually decided to take their similar thing to ReSharper and move it over to the Roslyn model. So that's why I think it can probably be done. Yeah. So it's more a matter of market economics that they decided not to, for now. Well, let's take one more question. Yeah, Jaime. Yes, I can give you details about the language that Roslyn has been implemented in. It's C#. It's C# and C# and C#. Or VB. Which is C# with a different skin, right? VB is it. So to be clear, Roslyn is both for C# and VB, and the reason I say C# is for simplicity reasons, and because everyone but two kind of raised their hands when we talked about C#. But VB the VB parts are implemented in VB. The C# parts are implemented in C#. They have some shared components. They're implemented in C#. So that's the precise answer to your question. Yeah. How difficult? That's a great question, and I'm actually going. I should pay you because it leads to something we'll talk about a little later if we get to it, which is where should C# go? It's hard to implement immutable data structures in C# because C# started out as a classic object-oriented language that heavily favors mutation. There are some of the things you want to do with immutable trees, because you can't mutate them, that require you in an object-oriented language to put extra methods on those objects. So, and we'll see that in a minute. I'll save some of the juiciness of that question for later. But the fact of the matter is, if you want to be immutable, you are not as well off in a classic object-oriented language as you are otherwise. Right? So we've learned a lot from this experience, and we see that increasingly more and more people are either working with immutable data structures or wish they were, but can't stomach the pain. And so that's a trend that we're looking at for a future evolution of the language. And I have a few slides on that towards the end, because it connects with this. Fine if we stop with questions now and go a little further. I want to talk about this thing that we came up with one of those times where we were desperate for cash. It's this idea that you can have custom analyzers that are, we talked about it a little before, you have some kind of diagnostic that you want to report on code that is not something that should be in the compiler. It's not a generalized warning or error as such that everybody wants to hear about and that applies to all kinds of source code. It might be more domain specific. It might apply to a specific library. It might be a specific company that wants to maintain a specific style in their code and that want to avoid the calling of certain APIs or whatever it is. Okay? Wouldn't it be nice if it was really easy to write custom analyzers similar to FXCOP or stuff like that? And if those custom analyzers could run at real-time speed in the IDE, just as the squiggles you get for errors at the language level, right? So that was our thought, like, can we do that? And the answer is, yes, we can. And that's infrastructure is already now supported since the summer, Visual Studio 2015. You can build your own analyzers, and it's a lot of fun. And we're going to build one in a minute, together here. Well, I'm going to do most of it, but I'm going to do it. I'll enjoy your company while I do it. So the idea is you can analyze stuff and report some location-specific things. Warnings or errors or just informational things that are maybe superfluous in the code, you could highlight, whatever. We also want to let you suggest fixes, which are essentially transformations of that tree, that syntax tree. So like refactorings, but you write them yourself based on this object model. And we wanted to make it easy enough that you don't have to be a compiler geek, because it looks like only half of you sort of are. But we want every one of you to find it easy to work with the language, not in terms of, compiler concepts, but just as an object model of the code that you can ask questions of and produce new transformed versions of. So you can even imagine some of these analyzers and fixes shipping with an API. So you write an API, there are certain ways that it should be used. Today you would write comments that nobody would read, and therefore you wouldn't actually write them, or documentation or whatever. Some people are good about it. Most people are not good about consuming it. Imagine if you could make some of that automated so that people who reference the API will also be referencing some analyzers and some code fixes that suggest to them, hey, you shouldn't be calling it this way. Let me rewrite it for you. So that's pretty cool. Let's try to do that. So I'm going to do that. And I have to warn you that 50% of the times I have been giving this demo, Visual Studio crashed in a very horrible way. So something's not right somewhere, but I feel good today. Oh, that was wrong. What's that? Did you log a bug for it? I haven't yet. I've been in Australia since, but I'm sure that there's a Watson bug that that's already being examined back at headquarters. Oh, this was the wrong one I kept open here. So what I have here is, so if you go to Visual Studio now, there's a new, you can install an extension that adds a new project type. Let me just get the diagnostic analyzer there. A new project type that is an analyzer and code fixer, okay? And it comes with a completely working but completely stupid analyzer already implemented. You can then rip out what you want and replace it with something else. And the only thing I did here is rip out what I didn't want and just start on replacing some of the boilerplate like names of things and stuff. So essentially, when you have one of these analyzer projects, when you hit F5 to debug, what it does is it takes that analyzer. An analyzer can compile into a V6, like a Visual Studio extension, or it can compile into a NuGet package that you can ship separately or with the library. What it does when you hit F5 is it starts a nested version of Visual Studio that has the analyzer we're implementing enabled, right? So you're debugging Visual Studio in Visual Studio here. Inception. So I'm gonna open up a sample program in the nested version of Visual Studio that sort of has its, we say that it's running in its own hive. It means it has its own settings, separate from the top level Visual Studio. And I have some sample code here. I also opened a window that's made with the help of Roslyn, that is the syntax visualizer. So if I click on a piece of code over here, it will highlight the place in the code I am in the syntax tree. That's a representation of the Roslyn syntax tree that is running underneath your code. And whenever you use Visual Studio, this is not just because I'm running in a nested Visual Studio. You can just run the syntax visualizer whenever you want, okay? Whenever you're in Visual Studio, and you can actually, like, let's just have some fun here. Let's go to a different place. This if statement here, if you want, you can generate a graph for it and see the syntax tree more graphically. Yes, that was a big one. Anyway. That's the kind of experience you can build on top of Roslyn too. But what I wanted was I want to create an analyzer that nices up this code by saying, hey, you should not have statements inside of if statements that don't have curlies, right? That's bad practice. So I wanted to complain about this code here and say, hey, put some curlies on. And by the way, here's a fix that will put the curlies on for you. So let's do that. So essentially what we're looking at here is that this expression here it's an expression statement. And whenever you're inside of an if statement, you want something else. You want something with curlies. I wonder what that's called. Let's ask the syntax visualizer. Let's put curlies and make the code right. And we see that now it's a block. Okay, so we want to check that if statements have a block inside of them. Otherwise, we want to complain. Let's go build that analyzer. But it takes a little while for the debugger to come up every time. So let's use edit and continue, and let's not actually go out of debugging while we build our analyzer. And this is why this thing sometimes goes wrong. Let's put a breakpoint here. Yeah. So what I did here, all I did is at initialization time, I'm able to register something that happens when I hit a certain kind of syntax node. You can also register things that run when you reference a certain variable, stuff like that are more binding oriented. But let's just stay with syntax here in the interest of simplicity. So whenever I see an if statement, please call analyze node, which is this thing here. So let's go to our nested Visual Studio and make an edit and see, since we have if statements in here, that should trigger the breakpoint that I just put there. And sure enough, we are now in the beginning of analyze node because it editing rejiggered it and it said, go run your analyzers again. The ones that are applied to stuff that it's on screen or near where the edit happened. Right? So I'm in here now. I have some kind of context that I can start working on. Let's see what that is. Context. It has a node. That's the syntax node I just hit. That's the if statement. So we can go and grab that. It also has semantic model if we want to know something about its binding. We don't. And it has something called report diagnostic. So if there's something wrong, I can use report diagnostic to report it. So let's see if there's something wrong. Let's take this node here, and it's of type syntax node. So we can see that it is indeed an if statement syntax, but we need to get it by the right type here. So let's just take if statement. Take var if statement is the context node as an if statement syntax. Okay. So now I have a syntax node in my hand. I want to ask it if it's. I want to ask if the if statement. It's just an object model, so it has a property called statement, which is the thing that's inside. If statement. It's like in Los Angeles, they have something called the La Brea tar pit. It means the tar pit. This is sort of similar. Anyway, if that statement, it has a kind. If the kind of statement that is inside of it is not a block, then we're in trouble, right? So syntax kind dot block. Then the code should be that whoever wrote it should be punished. I wrote it, but I like being punished. So let's make it really severe. I'm going to report a diagnostic here. This is unacceptable, man. You should. Let's report a diagnostic. I'm not sure what a diagnostic is, but let's report it. Let's see. Is there something I can do about that? Yeah, I can generate a local. We have a lot of new refactoring, so I'll generate a local for it. And let's try to create a diagnostic. So you see, it's an object model. I can just explore it here. This is typically there are factories around when you have stuff like this. So let's create a diagnostic. What does it need? It needs a descriptor. That's something I have in the collapsed boilerplate up there. I already have one of those. It needs a location, whatever that is. Let's keep that for a second. And then it needs to be told that this is an if statement. Okay. The location for the diagnostic, well, that's where I want a squiggle to appear. Okay. So let's create a local for this, and let's find out where do we want the squiggle to appear. It would be nice if it appeared on the if keyword, right? So let's find the location of the if keyword. Well, we have the if statement. It has an if keyword. And this is where it comes in that this is a very, very concrete syntax tree. It has a different physical object for every occurrence of the if keyword in the source file. And that seems stupid maybe, but it's really useful now because this particular if keyword is the one that has the location, get location here, that I want to squiggle. So they're very similar except for where they occur in the code, right? That makes sense. So now I got a location, I built a diagnostic out of it, and I reported that diagnostic. I am ready to be punished. Are you? So let's run from here. Code changes were applied successfully. I love edit and continue. Whoa, what happened? I got a squiggle on one of them, right? So it worked. So I wrote 3 lines of logic or something, 5, 4, whatever, how you count, and I was able to report on this thing in a way that it actually seems to work because one of them is squiggled and one is not. Let's erase these squiggles and see. All right. Yeah, now it squiggles the other one as well. Cool, right? Yeah. The point being, you can do this. You can do this, right? Something you hate people doing at your company, sneak in and install an analyzer in the machine. They won't know what hit them. Check it in while they're asleep. So the other thing I want to quickly do is I want to way out of this. It's too hard for me to actually type those curlies by hand. So I want to offer a fix for it that will do it for me. That's sort of the remote control generation here. So I'm going over to the code fix provider here, which I have half written in the interest of time, but it's pretty straightforward to look at what it does. So again, I have something that registers code fixes. And for responsiveness purposes, 10 minutes, good. For responsiveness purposes, it's an async method. So I say that whenever I see this particular diagnostic that I wrote before, call fix async. And this method here, it gets a context again, and the context has the diagnostic in it, so we get that out, the diagnostic we just created and reported. So the fix that gets offered is linked to that diagnostic. I can also get the document that is the whole source code, represents the whole source code here in the buffer, in the file. Okay, so given those, let me start digging in. Let's take the document and get the syntax root, the root of the actual syntax tree. From that, go find the token that is in the location that the diagnostic had. So that token is the if keyword. So from the if keyword, go and get its parent. So this is where it becomes important, that you can get a parent out. Like, how else would I have found the actual if statement, right? So I get the parent, and you look at it as an if statement. And now we go to town. Now we want to actually produce a new document that is like the old one, except for a few little changes. Okay? So we've zoomed in on the if statement and a little up again. But now we want to create a new if statement. Oh, I can't, because I need a breakpoint. I need to, let's just go all the way here. Why don't we? Let's go and, let's go to the nested thing here and again make some edit. No, an edit is not enough. I want to go to the light bulb here, and what you see is that when I offer to add, when I ask to have braces added, it comes into the code that is supposed to generate the fix that it was just about to preview for me. Okay, so now actually this menu sits in front of the outer Visual Studio, and it's completely stuck there. But no matter. We are now stopped, so we can go and build some code. So let's write a new if statement. And the new if statement, now help me out here. What should the new if statement be? It should be the old if statement with, and this is a pattern that is one of those extra things you have to do when you work with immutable things. The with pattern, which creates a copy except for one little change. So we say with statement, because we want to replace the statement. There it was, with statement. And then we give the new statement that's supposed to replace its nested statement inside of the if statement. Okay, well, what is that? That is a new block, right? So there's a syntax factory, there it is, dot create. That's how you build new things. No, that's not how you build new things. No, we actually have just names like that. So I want to create a block, and what should be inside of the block? The old statement, yes, you can do this too, right? If statement, dot statement. There you go. That's it. We created a new if statement. Now, we don't have a new tree yet, we just have a new little node, so we have to create a new root, which is the old root, where we replace the node if statement with the node new if statement. Okay? So now we have a root of the syntax tree. We actually need a document. So let's do right here, let's return the document dot, if I weren't selected, return document dot with syntax root, new root. So I created a new document with the new root with the new if statement. Okay? You agree? So where did we get to? We got to around here. Let's run from here. Oh, and let's get rid of the breakpoint because we didn't run very far. Well, let's keep going. So in the meantime, the window went away, but let's click again. Add braces. Ta-da! Look what we see here. We see a preview that it generated by auto-diffing the old and the new tree, showing me what's new and what's old. If I select it, it puts the code in, or I can go and select, do it in the whole document. It gives me a preview in a separate window then, telling me all that will happen, and then I can apply that. And that's all just infrastructure around it. We just had to write the logic. That's you get it now, right? Yeah. So go tell your favorite Java IDE to do this. Okay, so enough demo for now. Let's spend the last 3 minutes. You already got to ask questions. I'm sorry, there won't be time for any more. You can grab me after. So let's talk about some of the lessons and how they apply to C# 7. Essentially, we're not building C# 7 to be a better language to build Roslyn. That's a classic mistake, right? You write the programming language that's the best language for building the language you. But we had some typical issues around using immutable code, for instance. And we had some issues that you saw about, like, figuring out, diving in for a particular kind of shape, like the if statement here. First you have to do the as, and I should really have checked if it was null. And so a couple of things here are related to that. We're thinking about doing in the next version of C# that we call 7. Pattern matching. Being able to say, if O is point P, give a little variable name here, and the point P here is a new pattern, and P is introduced as a new variable that is O, but typed as point, so you can use it in here, okay? That's a pattern, and of course P can also be used in the rest of the if condition here. Maybe we want to have some patterns that can match recursively and put the X into a variable and the Y into a variable. Maybe you can do that positionally if the point class can somehow say what order its things come in. Maybe we can use constants in the patterns. So that's one place to use patterns, and we need to figure out exactly what patterns we want to offer. But once we have the notion of patterns, we can put them in different parts of the language as well. We'll try to integrate them as well as possible into the features we already have. But you could also put patterns in the cases of switch statements, right? So if I could switch on anything except just a few types, and if I could write patterns in my cases where I say, if this was an int, let's call that I and do something with I. If this was a point, let's call the parts of the point X and Y and do something with those. If it's a string and that string is not zero length, you could have when clauses on your, so you kind of see the idea. You use patterns to more succinctly match shapes of things. We think that's good for wire data as well. That comes down and might have different data and different shapes. And it's also similar to what you might do in some functional programming languages, maybe. So we're a little inspired there, to put it mildly. You could also imagine having an expression-based version of it, where the switch actually has expressions inside of its cases rather than statements, and one of them gets selected as the one that produces the result. We're also thinking about tuples. It'd be nice if you could return more things out of a method, just with syntax like that. We think tuples should have named members, but the names are kind of like syntactic sugar on top. So you could dot into, I get a tuple out, I can dot into it, but there might also be some deconstruction syntax like pattern matching. You could just immediately split the tuple out into variables. We think we'll do that. Works well with async because this is a tuple type, so you can just slap task around it, unlike out parameters which don't work with async. Yeah, tuples and patterns go well together. Here's a state machine. You have a state and a request, and I use match instead of switch as a keyword there. Never mind me. Maybe for those immutable data types, maybe there's some notion of records that default to immutable and default to having value equality and that kind of stuff. And so what they really do is they generate some what would be all this code today in C# to write, so that you're not burdened by choosing the immutable path. Yeah, and you want to be able to use object initializers for those, so we got to figure out how you do that, because object initializers today work with mutation. Oops. And maybe that with thing shouldn't be that you have a bunch of with statements, with methods, one for each property. Maybe it's somehow built into the language. So those are some of the things we're talking about. Yeah, we're also talking about tracking null types, but hey, I'm out of time. Yeah, those are the kind of things that we're thinking about for the next version of C#, just to give you a glimpse of that. But we're now at 6 o'clock, so even though I'm only a third of the way through my presentation, no, just kidding. I think it's a good time to call it quits for the plenary session. I know that I noticed that's another reason why I didn't relapse too much into my teacher aspect, because there's an Xbox in front of me. So it's more my student aspect maybe. But I want to say thank you very much for listening. And then I think someone will come up here and help these find an owner, right?
So do you want to take a few? You'll give me a minute to set up. If you want to take a few questions.
That would be great. Any questions? Yes, one up there.
Some of the pattern matching stuff, is that already baked into .NET 4.6.1? Just compile it down into 4.6?
Is some of the pattern matching stuff in 4.6.1?
Yes.
I don't think so. What makes you ask?
Just some of the things that I'm saying about the latest release.
Right. Yeah. No. We don't. Pattern matching is it has to be a language feature essentially. It may require some API patterns to be present, and so it's likely that there will be a version of the framework that facilitates more pattern matching, if you will, and they will kind of come together. But there's nothing there yet. There was one down here that. Yep. You can package and analyze as NuGet package, yes.
In the same NuGet package as your library, or does it need to be?
I think you can put them together. Yeah.
So you can give your project out, and as they
Yeah.
and they also get the default set of rules as to how.
That's the idea. And then there's a little UI for analyzers that you can like turn them on and off individually or together. So if people are really annoyed by it, you can't force them, but they could be on by default. There's one up here and one down here. Yeah, you? Yeah.
So if some of those things are language features, how does the new Roslyn compiler get distributed? Do you need a Visual Studio update, or is it just a simple...
Oh, so we're not doing any of the existing Roslyn stuff with new language features. Those are just ones that we're thinking about as a kind of learning from having built Roslyn, if you will. Roslyn is not gonna. We're probably not gonna. We're going to try not to break it for the next version of the language. Let's just put it like that. I want to. It was you there, and then I want to make sure, because I didn't even look over there first. So they've probably been waiting forever. Yeah.
Yeah, I was just wondering if you actually test the new language features on the compiler or something. Do you quickly compile a version that contains the features and then you give it a go and see how it goes?
Do we test the new language features on the compiler? Sometimes we do. It's a problem because we have to make sure we can compile the compiler, and at Microsoft we kind of have an official compiler that we call the toolset compiler, and we don't want to go update that too early. But we have been known to do it. For instance, there's a feature in C#6 where we have exception filters, which Visual Basic and F# have already had, where you can put a Boolean expression on a catch clause and say whether to catch it or not, which is really useful. And we needed that so badly in the Roslyn code base that we actually implemented it and immediately started consuming it. If we want it bad enough, we will do it. We have principles, but we're also pragmatic. Yeah.
Are primary constructors still going to be a thing at some stage?
A primary constructor is going to be a thing, probably in some shape or form. I think we have to think it together with the records feature that I quickly showed. Primary constructors, for those who didn't follow, is sort of the idea that the class itself can have constructor parameters. And some other languages, like F# and Scala and others, they have that syntax, and it's pretty useful. But we felt that if we put that in C#6, which we were originally planning to do, we might stomp on a more full-fledged record feature that we hadn't designed yet. So we want to get those scenarios handled together. That's how we delayed it, essentially. Yeah. Do you have time for more? Are there more? Yeah, several. Yeah. I didn't keep track anymore. I think you had it along there, but I'm just, yeah.
Yeah, with that, over application, that was async. Does that mean
So multiple people collaborate on this in real time, like Google Docs style?
Could multiple, because the change of the code was async.
Yeah.
Does that mean that multiple threads could work on it?
Could make a change to the document at the same time?
Possibly, though this is primarily, so the idea with the async here is that the whole thing might take a while, and we want the IDE to stay responsive. And so we don't want you to, if you're doing async things in there, we don't want you to hold up the IDE thread or something like that. And we want to be able to cancel it if somebody types something and the window goes away. That's why there's also a cancellation token threaded through there. So it's more about being responsive on the UI than about concurrency in this case. Yeah?
So really quickly, how well does this interact with the type system? So really, really quick example. Write a convention test to say spin through my code base. So grab an assembly, get all of its defined types, find all of the DTOs, and then say, okay, each of those DTOs must have a protected default constructor so that my serializer can call it. How would I then get that to interact at the kind of the type level versus the syntax tree?
Essentially, so how do you do something that's based on looking at the types that are declared and kind of based on the binding semantics there? How can you get semantic information out and base you analyze on that? The answer is you just do it. You trigger. There's a different kind of trigger for your analyzer. Instead of triggering on particular syntax nodes, you can trigger on particular kinds of declarations, for instance. And then whenever you see that kind of declaration, then you can start drilling in and seeing, is it doing things right? And if not, then you can flip to syntax and say here, under the location of this thing that I just semantically found, say something nasty and provide a fix for it, right? So it's there. It's totally there. Okay, you're impatient now, right? No?
So there's two more hands, so we did two more.
Okay, two more. Yeah.
You mentioned the Roslyn compiler was super fast and parallelizing. Have you run it against the Windows code base to see what sort of improvement time-wise you're going to get out of the Windows build?
Have we run the Roslyn compiler against the Windows code base?
For 90 builds of the Windows OS.
But they're not written in CSharp. What do you mean? Yeah, so we can't. I mean, if we had something for C++, I guess we could. But most of Windows is written in C++. But to be honest, there are probably we've tried it against. We have a bunch of code bases, big code bases that we measure against. That either we have done it just to see, or we actually have it as part of our regression suite to check them. So I'm not sure that the whatever .NET code is in Windows is part of that, but it could be. I'm not sure. But it's generally if you have a lot of cores, there's a good chance that we can speed up every compilation that happens as part of your build, for instance. Depending on some things, but typically we can. Yeah. Was that the last one up there?
Take Chris's.
Chris?
Yes, it's me.
That's you.
Having the light bulb is awesome, but it's a bit boring. Is there any chance I can bring back Clippy?
Yeah, so as I said, it's open source. Nice one. Thank you.
All right, big round of applause. Thanks.